Welcome guys, and today we're back with another USACO walkthrough. Today we're going to be doing the Taming the Herd problem 3 of February 2018. Let's jump into it. Alright, so let's click on the third problem. And I've seen this one before, and I've done it, and I've completed it. So today is going to be a little bit different. I'm going to kind of explain more of the algorithm using slides I've prepared. So let's jump in. So let's start reading. Early in the morning, Farmer John woke up to the sound of splintering wood. It was the cows, and they were breaking out of the barn again. Farmer John was sick and tired of the cows' morning breakout, so he decided enough was enough. It was time to get tough. He nailed to the barn a counter tracking the number of days since the last breakout. So if a breakout occurred in the morning, the counter would be 0 that day. If the recent breakout was 3 days ago, the counter would read 3. Farmer John meticulously logged the counter every day. So Farmer John has basically a log tracking, basically like a war clock almost. Basically every time the cows break out of the barn, he resets the clock. So if, let's just say entries on the log was 3, that means a breakout was 3 days ago. And the one thing we have to note is that there was a breakout on the day that he started the log. So in that case, the first entry either has to be 0 or -1. So if we look here, it says that -1s are basically where the cow has stolen the entry for that day. For example, if we look at this, the end of the year has come, and Farmer John is ready to do some accounting. The cows will pay, but he says. But lo and behold, some of the entries some entries of his log are missing. Farmer John is confident that he started his log on the day of a breakout. Please help him determine, out of all sequences of events consistent with the log entries that remain, the minimum and maximum numbers of breakouts that may have taken place over the course of the logged time. So they're going to give us basically a log here of this length, and we need to find the minimum and maximum times the cows could have broken out. So let's see the input format. So the first line contains single integer n, denoting the number of days since Farmer John started logging the cow breakout counter. So this is the length of the count. This is the length of the counter, and this is the log counter thing. And as you can see, it has 4 values. The second line contains n space separated integers. The ith integer is either -1, indicating that log entry for day I is missing. So again, like I said, -1 signifies that the cows have stolen that day's entry, and therefore we don't know what happened on that day. So indicating that everything is missing, or a non-negative integer AI at most 100. So AI might sound like a confusing math term, but in reality it's just a number, basically at most 100, indicating that on day I the counter was at AI. So basically this is saying that let's just say, take this one for example, basically on day 2, this is day 1, this counter was stolen, or this entry was stolen. And if we look on day 4, this was not stolen, so it's 1. This means that there was a breakout 1 day ago, so 1 day ago would be over here, and therefore we can determine that this is 0 based on the fact that on day I, basically on day 4, the counter was at 1. In this case, it's 0 when the counter when there's a breakout on that day. So therefore, this will be 1 and this will be 0. So let's look at this example here. I prepared some slides to show it. So we have to loop back from the array list. So this is just getting into solving the problem itself. So in order to find out the minimum and maximum values, we need to find a way to run through this. Let's log, if you will. So if we run from the back, we don't know whether this is a 0, that's 0, or whether these are positive numbers, whether we don't know what these are. So, but however, we can know if we are in a streak, basically a group of positive numbers starting from a 0. Let's just take this one for example. If we read from the back and we read 1 in, we know that this has to be a 0 or it's inconsistent. Basically, it's wrong and Farmer John is just bad at logging his counter. So in that case, we have to output a single integer -1. Otherwise, we have to output the minimum and maximum values. Alright, so if we go back to our slides I prepared, we can see that I literally just wrote down what I just mentioned. So since 1 means that there was a breakout 1 day ago, basically this one, it means that the third negative should equal 0, basically this one. As the breakout, when it says 0, that means there's a breakout on the morning of that day. So 1 means that there was a breakout 1 day ago, basically this day. I hope I'm explaining this as the best I can. There's really no way I can simplify it even more. It's really simple. And positive numbers preceding the other positive numbers would be 1 lower, or it's consistent. And we return inconsistent, or it's inconsistent and we return -1. So what I'm saying here is, if this is not 0, then it's inconsistent. Like if it's a 1, there can't be 2 of the same counter in a row, as time always has to move on unless Farmer John has like time stopping powers, which I doubt he has. And also the first entry, this is an important thing, must follow a breakout, so we always have to switch it to 0. So if we go back to the problem, they say, let's just find it real quick. He says Farmer John is confident that he started his log on the day of a breakout. Basically, the first entry has to be 0 or it's inconsistent. In this case, it's -1 as it's missing. So we always know it's 0. So basically, we can change it to 0 without doing anything else. So since we changed, now that we have changed this to a 0 and this to a 0, let's just put that back to -1 for simplicity. Our array looks different now as we change 2 values. Now if we count, so the minimum breakouts is just going to be the number of zeros. Number of zeros is basically the day they broke out, so we can just count those. And the maximum amount of breakouts is going to be those zeros plus the amount of other possible zeros. In this case, this -1, which is missing, could be 0, so the second entry could be a 0. And therefore, we can count it as 1. So basically, in this example, it would be these 2 zeros plus whether this one is 0 or not. So the answer would be 2, 3. Basically, these are the 2 minimum zeros that we know are signify a breakout. And the other one, which basically the one that we don't know, is this -1, whether it's a 0 or not. But since we're counting the maximum, we have to consider that it is a 0. So we just consider that, and then we just add that to our original number, basically 2 zeros. So 2 plus 1 would be 3, and that's why we get 3. Alright, let's just go on. So let's just try a harder example. So let's just say we already know that we run from the back. So basically we go from here to here. And we first see that 1 is a positive, and we start counting it as a streak. So a streak is basically the cows don't break out for an extended period of time, and we can count them with positive numbers such as 1, 2, 3, 4, 5, 6. So therefore, the -1 before it we change to a 0. So since, like the first example, this is a 1, basically there was a breakout 1 day ago, so that means this -1 is a 0. And then we change it over here. And next we see that we have a -1, but it does not bring up any inconsistencies and can be ignored. Basically, this -1, since it's missing, it could either be a 7 or a 0. We don't know that. However, it's not creating any inconsistencies. Basically, it's not a 6. It's not a wrong positive number or anything like that. So we can just go through that when we're running through the array. We then see a new streak of 6. So if we read from here, we can see that 6 is right here. That's the start of a new streak. And then we just go forward even more, and we can see that 5 is 6 minus 1, 4 is 5 minus 1, and it's a perfect little streak, and it's not inconsistent. So if we see there's nothing wrong with this streak, and it can be counted as a streak of 1 breakout. Basically, these numbers signify that there is 1 breakout, and for 6 days there was no other breakouts. So after processing the array, we can count the number of zeros. Basically, if we see here, this can be a 0, and we know that we changed this to a 0, so this would be our final result. And we count the number of zeros, in this case 2, 1, 2. and 2 was the minimum. So we add the amount of negative ones that can be zeros, in this case this one, the one that's not hurting anyone. In this case we get 2, 3 again as our output. So as we're just processing through these, we need to find a way to code them. So let's just try a few more examples. Running into inconsistencies. Let's just say that Farmer John is bad at logging and he does something wrong. So for example, if we have this really long one, it's not that long as there are streaks, we can see there are 2 5s in a row and therefore inconsistent, as each log represents a day going by. Farmer John cannot stop time, like I said, unless he's like farmer wizard guy, and therefore we return -1. We always need to check for this, and this is really important. For example, if let's just say we run through here, we see a 0, he's not hurting anyone, and then we see a positive number, so we start a streak. So we can see that's 15, 14, and then we see that these two are -1s. However, they are exactly 12. They are exactly the same space for 12 and 13, so we fill that in. And then we see that 11 and 10 are not hurting anyone. They're perfect. And then we go down the streak, and we see that we get a problem until we reach the 2 5s. If we see that this -1 is not hurting anyone, so it's basically a 6. It can't be anything else. And then we see that there are 2 5s in a row. As soon as we see 2 numbers in a row, basically they're not consistent within one another, then we immediately just break out of our loop and we return -1. So it's time to prepare our code. Okay, so to prepare our code, we need to set some variables first. So we need a variable to store the previous positive number to decrement. So what I mean here is that we need a variable basically to hold the previous positive value before we run into another one. Basically, if we want to calculate a -1 that is not a 0, basically our entire algorithm is going to be, we run through the array, and if there's a streak, we turn all the -1s within a streak into zeros. So 29, 28, 27, and the next one would be 26, right? But we don't always know that. So in this case, we need to declare a variable to hold the previous values. So in this case, to find 26, we do 27 minus 1. So our previous variable would be 27, and we subtract 1 from that. So now we also need a boolean to see whether we are in a streak or not. As being in a streak and not being in a streak, we're going to do extremely different operations. So it's going to start as false, as we're not already in a streak as we start running from the back to the front. As soon as we see a positive number, we're going to change that to true, and we are in a streak. So let's just do this example. As you can probably tell, this is just one whole streak of 29. If we start in the back, we can see that 29 is positive, and therefore our boolean flag is set to true, and it's the beginning of a streak of 29. Also, we set previous to 29 to calculate the next value. We then see whether the next positive numbers are a decrement of 1. Basically, we're saying that we check if the next positive numbers downward from 29 are equal to 29 minus 1 and then 28 minus 1. Basically, they're all decrementing by 1. They're not being the same number or like subtracting 2 each time. Okay, and then if they are -1, we change them to the previous -1. Basically, I'm highlighting these to show that they're not just the word previous, they're variables. So we go all the way until there is a 0. In this case, we reset our boolean flag to false. So in this case, this tree continues the entire length of the array, basically 29, 28, 27, 26, 25, so on. And therefore we get 1, 1. So we only count 1, 0, and there are no other possible zeros to become there are no other -1s to become a 0. So if we open our IDE real quick, we can just switch to our February project, as this is the third problem of the February one. So if we just open it, and let's just say 2018 February, we just change the window real quick. And now we create a new class. So we can just create a new Java class, and I believe it is called Taming. So yeah, it's taming.in. So we just call it Taming for simplicity and organization purposes. And we do public static void main. And we throw the IO exception, of course. And now we can just copy our buffered reader and print writer functions to our code. And now we get taming.in and taming.out. And now if we go back to our let's just do our slides real quick, and let's just do that. Okay, so we need to find a way to store this input. So in this case, 4 and 1 1 negative 1 negative 1 negative 1. So we can just create an array of length 4 to hold in the entries, and we can just create a variable to read in the end value, as I say here. So if we go back to our IDE, we just create a new integer, go n, and we read it in using the br. So let's just do integer parse int br dot read line. Now we do int, let's just call it array, or arr equal uint n. And now we use a for loop to read in our values. So since it's only one line, we only have to declare string tokenizer once right here. So if you're new to my channel, string tokenizer just tokenizes our input into characters separated by spaces. So basically they're reading something every space. See now next token. Oh, sorry about that. This is br.readline. And then we just create a for loop of length n, as our n value is supposed to be inside the array. And basically we just put them in. What is wrong here? Oh yeah, we also have to put integer.parseInt as they are integers. As a string tokenizer reads in everything as a string, not an integer. Okay, now we have read in our input and put it into some organizing. We have read in our input and organized it using a variable and an array. So we also remember the most important thing is that the first entry must be follow a breakout. So we always have to switch it to 0. So let's just go here and let's just put an if statement and see if it's a -1. If it is, then we switch it to 0, or we can just switch it to 0 either way. So let's just do that. If 0 array 0 is not equal to 0 and array 0 isn't equal to -1. So we're checking if it's not a 0 or it's not a -1, then we return -1, basically pw.print. So this is a really rare case, but we still have to account for it. So pw.print -1, and then we just close both of our pw and br. So pw.close and br.close. Alright, so now we can just go ahead and straight up change our array 0. So if the array, if the first value is fine, we can just change it straight up and into 0. And now we can declare our variables. Like we said, we have a boolean. Let's just call it flag, and equals false. And then our next variable is its breakouts. This is the thing that we're gonna utilize. Basically count our breakouts. Actually, I don't think we even need this variable, I think. Let's just create min and max. So basically let's just do this. let's just do int min equals 0, int max equals 0, and remember we also have to declare int prev. This is they're going to declare the previous value and save it for us. Just put 0, and now we can begin running through the array. Okay, so before we can do any of that, it's good to comment your code. So let's just comment what we have here and just say what it does. So we declare this variable to store the whether we are in a streak of no breakouts, and we declare so this is just min and max variables to return, or basically this is going to be our output. And we declare for this variable to store the previous entry value to see whether entries in a log, positive entries actually. So we're going to count positive numbers, and we're going to see whether they're 1 apart, as Farmer John cannot stop or speed up time. Whether positive entries in the log are 1 apart. So now alright, so in order to do that, we first run through the array and process what's inside. So we're just going to create a new if state, a for loop, and run through the array real quick. It's nothing too fancy. Just in length I, sorry about that noise, and then we just check whether it's a positive number or not. So if array I is greater than 0, we need to check whether the flag is false or true. So if it's false, then we're starting a new streak. So if we just go in there, and then we need to check it. So if it's false, we're finding a new positive number start of a streak. So if it's a small comment, if you want to add that, it's optional, but I recommend it. Then since we're in a streak now, basically find our first positive number. We set our flag to true now, as we're in a streak, and this basically a flag just says if we're in a streak or not. So we're in a streak, so it's true. And our previous number is going to equal to array I. So this is going to calculate our next value. So now we need to say what else. Basically, we're already in a streak, and therefore flag is true. We don't need to say else if, as there's only two possible outcomes for if statements of booleans. So we can just put else. So basically else if, no, not else if, but just put if statement within the else. Basically if array, oops, sorry about that. Basically array I is not equal to prev I. Oh, prev minus 1. So what we're saying here is if array I basically is not equal to prev minus 1, basically it's not a decrement of 1. If we go back to our slides, we can see that all of these positive numbers within a streak are 1 apart from each other. So we're just checking if they're not 1 apart from each other, we need to do something. Basically this is inconsistent. Return -1, as that's exactly what the problem wants us to do. So if we go back to the problem, they say that if there are no sequence of events consistent with Farmer John's partial log and his knowledge that the cows definitely broke out of the barn on morning day 1, output single integer -1. So now we're just going to return -1, basically pdo.println -1, pw.close, and br.close. And since we're still in the if statement after we just do that, because Java doesn't see the PW as a return statement. We need to return nothing. So we're just get out of the loop. Alright, so now we can just go down here and scroll down. And now we need to see, let's just go back here. Let me get a bigger format to see. So now we need to do, what if it's not positive? So let's go back to this place and let's go else. So basically we're doing the else for this if statement. Basically, if array I is not positive, we check if it's 0. Basically, so if array I equal to 0, then we set the flag to false, as that's the end of a streak. And then we set our we reset our prev as well, as our streak is ended, so we don't need to count any more things. So prev will always reset whether we get into a new streak, if we get to a new streak. So if we can just add another if here, basically if it's not equal to 0, but it's not positive either, therefore it's -1. So we can just add a little comment here, basically if array I is -1, we can just put an else statement. Excuse me. So if flag is true, array I equals to prev -1. Prev equals array I. So what we're doing here is basically, if it's a -1 and it's within a streak, we have to set it to prev -1, and prev becomes array I. Basically, we still have to update it despite being -1. Basically, let's just do an example real quick. If you don't understand what I'm saying, let's just say that we run through this and we find that there's a -1 within our streak. Basically, we're checking if it's true or not. So if it's true, basically if flag is true and it's a -1, then we see that this has to be 26 or else it's inconsistent. But we're assuming that it is consistent, so we have to change this to 26. Basically, let's go here, and then we change it back to prev -1. Basically, we don't have to do that. So we just put array I to prev -1. Basically, we're decrementing like so, and then we're changing it to prev. It's very simple, and let's just continue. And now we need to check one more thing within here. Basically saying, if array I is equal to 0 now, basically if previous equals to 0, and we basically if it's a -1 and we set it back to a decrement of our previous, and if it's a 0, then we need to check and we need to put flag to false again. So as you know, if our value is 0, then we have to reset the flag to false. So add a comma here. So after the update of prev from, let's just say, -1 to positive number, we need to restart this search if it's 0. And now we can just, and that's the end of our for loop, I believe. So if we see that we have a lot of brackets here, it's kind of cool. Writing a bunch of lines of code makes me feel like an actual programmer and not just like a kid that writes like 2 lines of code. Alright, so now we can just check. We declared 2 variables to return or output, min and max, and now we just need to calculate them. So like we said in our slides, minimum is the number of zeros and maximum is the number of zeros plus the number of -1s. So don't be confused. Just because there are -1s here, let's just say here in the middle of a streak and here, we don't count them as we change them to the positive numbers that they need to be. In this case, 26, 24, 23, 22. However, if let's just say there are ones like here, no, not. Let's just say let's just take our test alpha for example. Here we don't know these. We're not in a streak, and these are just free negative ones that could be anything. So we still need to count those. So if we just go back to our code, we need to check for negative ones and zeros. So if we just let's just do a for loop. So we're just going to run through the array again. So for int I equals 0, I equals n, I is less than n, basically the same thing. So if array I equals to 0, so we're checking if it's equal to 0. Min plus plus, so we're adding, as you remember, as I said, if it's 0, then we add 1 to a minimum, as minimum is just the number of zeros. Number of zeros represent a breakout on that day, and then we do another statement. So if array I equals negative 1, then max plus plus. It may seem like max is less than min right now, but remember, we still need to add max to min in the end. So max plus equals min, and then we do print pw.print lines. So this is our final output if nothing else fails, and our input format is just separated by a space. And then we do pw.close and br.close. And now we're pretty much done. So if we just, let's just say plug in our test output. So let's just change these to test. If you want to create a test, basically you go here, you create a new test, just file, and you just type in test like that, or test.in. And then, so basically, since we are in IDE, it automatically detects those files, and we can use them for testing. So if we just go back to the problem and plug in our sample input, go like that. Wrong one. And we put in, let's just say that, and we can test it. Oh, it seems we have an error. So the system cannot. Oh, sorry about that. I forgot to change these to test. I think. Yeah, so we are in the right ones. I think I changed the wrong file. Sorry about that. So if we run this, process finish exit code 0. Basically, we don't have any errors. And if we check our output, we get 1 3 instead of 2 3. So let's debug now. Alright, from my visible point, I can't really see any errors. Let's just take a look at the loop real quick. So if we scroll, I have a sensitive scroll wheel. Oh, actually, I see the errors now. So since we say we're running from the back, and that's the only way we can do it, we need to decrement a loop. We need to use a decrementing loop, not an adding loop. So I is actually greater than or equal to 0. So we're running until 0, and I minus minus. And also, I think we also have to add something here. Okay, so let's just do that. So in this case, if array I is not equal to prev minus 1, basically it's inconsistent. Basically, if it is consistent, we still have to update our prev value. So let's just do that. So, prev equals array I, and this should work. Stop and rewind, and see if there's any errors. Nope. We go to our output. We can see that we get 2 3 as our correct answer. So we can just find our go choose our file, and then we go desktop. Mine is stored in desktop, or I do. Sort Taming. Alright, so we can sum in our solution now and see whether we did well. Oh, and one more thing we have to do. We have to change these to the one they gave us, basically Taming. Sorry about that. Tame. So now we can just choose our file again, and then we press submit, and we should be able to get all the test cases. I'm not so sure actually. Oh, and I'm pretty sure we got. And yeah, we got all the test cases. Great. So thank you guys for watching. If you made this far, I appreciate you. Yeah, our video is going to get better really soon. And yeah, thank you guys for watching. And uploads coming soon. Please subscribe if you enjoyed. It's free. It's completely free. And if you can always unsubscribe later. See you next time.